My name is Jo Franchetti, and I am a developer advocate, currently unemployed, but soon to be employed at a new place. So, news in 2 weeks. You can get me at This Is Jo Frank on all of the socials, whatever socials that we're using these days. And today I'm going to talk to you about the importance of developer experience and how we can influence developer experience and how the choices that we make when we're writing code can change how other developers feel about the code that we're writing. So let's start with a story to illustrate this. And this is something that many of you may have experienced in your developer lives. So you are a software developer. You've been tasked with integrating a new developer tool. So let's call this tool Codemajig. And someone at your work told you that Codemajig is recommended for its advanced features and its time-saving capabilities. And you're excited about the potential that this offers. So you embark upon the journey of onboarding with Codemajig, and you start with the obvious. You open up your favorite search engine. You try and find some online tutorials, some documentation to try and understand the basic concepts and the functionalities of Codemajig. But you quickly realize that there's not many online learning resources available, and the ones that are quite poorly written. They're poorly structured. The official documentation is not only incomplete, but some of it is out of date. It lacks clear examples. It doesn't have practical use cases. And you do find some tutorials, but they're either really simple, basic things, or they're overly complex and they leave out steps and they leave you feeling frustrated. So you're determined to overcome this setback. You reach out to the Codemajig community to see if they can give you any assistance. You join their online forum, you join their Discord, hoping to find guidance from more experienced users. But unfortunately, the community turns out to be quite unresponsive. They're unwelcoming to newcomers, and your questions just go unanswered for weeks. But you are a consummate professional, so you decide that you're going to just dive in and start experimenting with Codemajig yourself, and you're going to create a small project. But you discover that the tool has a very steep learning curve. It's got a complex code base that lacks structure. It's challenging to navigate, and it's difficult to even find out what the features are of this tool. It lacks proper error handling. It doesn't have good test coverage. You're getting cryptic error messages that don't actually help you with troubleshooting. You find numerous bugs and inconsistencies, and you attempt to report these to the Codemajig community, but their response is so slow, and they never actually respond to any of the issues that you raise. And the weeks turn into months. Your enthusiasm for learning Codemajig wanes, and you begin to question your colleagues about why they chose this tool in the first place. And this whole experience, the lack of learning resources, the unhelpful community, the inherent flaws in the tool itself, have all made for this frustrating and demoralizing experience. And you realize that despite promising all these features, Codemajig has such a poor user experience, such a lack of support, and its technical issues make it just impossible to use. Ultimately, you and your team decide that you're not going to use it. You abandon it in favor of other tools that have better documentation, a more supportive community, and a much shallower learning curve. And this is what developer experience is all about. Having a poor developer experience has cost Codemajig a customer. It has ruined their reputation in your eyes, all because they have this bad developer experience. And I'm sure many of you have had similar, if perhaps less extreme, experiences in your journeys as you're coding. And this first experience that you have with a tool or a framework or a language is essential to developers deciding whether or not they want to continue to use the code that you've written. And it will sway the way developers perceive the quality of the code that you've written and the quality of the code within your organization. So developer experience, or DevX as it's often called, or DX, describes the journey that a developer takes as they onboard with your code, as they write with your tools, as they onboard with your teams. And it's the lived experience of developers and the points of friction that they encounter in their everyday work. And so what I would like to talk to you about today is the different points that encompass developer experience, how we can improve developer experience, and then I'm going to go into some actual technical examples of things that I've seen that I think improve developer experience. And developer experience isn't just at that getting started phase. It runs all the way through your work. So while you're developing with your choice of tooling, while you're building, while you're testing, while you're debugging, while you're releasing. And as people who are building tools and frameworks and libraries, even if we do manage to make the sale and we get people to onboard with the things that we're writing, we have to have a pleasant developer experience as they're using it to keep them in the future. Otherwise, developers are just going to jump to a different tool that has a better developer experience. They're going to abandon the things that we're making. Poor developer experience will cost us money, it'll ruin our customer base, and it can damage our reputation. And a common misconception is that developer experience only affects the tools and the products themselves, but it has such a massive human factor as well. Things like having clear goals or feeling psychologically safe when you're using a tool, not feeling belittled, feeling like you are capable, can have a massive impact on how a developer feels about the code that you're writing. And improving DevX can also have a huge impact on things like productivity, on satisfaction, on engagement, and even on employee retention. So let's take a deeper dive into what can actually affect developer experience. And there was a brilliant paper that was released recently by the Association for Computing Machinery. I put a link down there and I will share these slides out at the end. And it breaks developer experience into these three segments. So we have flow state, we have cognitive load, and we have feedback loops. And when we consider all of these three things together, they can describe the full range of frictions that developers experience as they're working with our code bases. So we're going to take a brief look into each of these three and then go on to some more practical examples. As I'm sure we are all aware, and has been mentioned in a few talks already, software development can be quite difficult. It's complex, it's complicated, there's always new things to be learning, new languages, new methodologies, new frameworks, and reading and writing and learning code all contribute to what you can consider a workload on your brain. So we call this a cognitive load. And cognitive load refers to how much information your brain needs in order to process and complete a task. And that is alongside all the other stuff that your brain is doing. So thinking about what you're having for lunch, thinking about what temperature you're sitting in, how much noise is going on in the background. Cognitive load is how much effort it takes for you to learn something and not only learn it, then retain that information for later use. And psychologists refer to this thing called working memory, which is how much capacity your brain has to hold information temporarily. And it works really similar to how the RAM in your computer works. So you have a certain amount of this fast access storage available to you. And as you're doing tasks, as you're learning things, as you're writing code, as you're reading things, you're filling up this fast access storage. And every time you pick up a new task, you're putting a new thing in there. And eventually you will run out of available space. And you will need to stop doing one task in order to start doing another task, or you're going to find yourself slowing down. You're going to find yourself making mistakes, and you're going to find things more difficult. And cognitive load can increase if you're working on a more difficult or a more complex thing, or if you're trying to understand something new. But it can also, as I mentioned, be increased by extraneous information that's being presented while you're working. So if you're working in a noisy environment, or if there's a large level of light or not enough light, or things like context switching. So you're reading documentation and maybe you can't find the thing that you're looking for and you have to open up a browser. So you've then got, a few different windows of things open, and that context switching means you're running a bunch of different tasks. You are filling up that memory. And even things like feeling tired can reduce your cognitive capacity, feeling bored or feeling anxious, they will all decrease the working memory that you have and thus decrease your cognitive load capacity. Is that beep coming for us, or is that... Okay, we will assume that came from outside. When cognitive load is high, developers are going to need to devote more time and more effort to learning something, to completing a task, and they're going to be more likely to make mistakes and less likely to be innovative, which is kind of interesting. So to improve developer experience, teams should be aiming to reduce cognitive load as much as possible. And we should be looking for ways to eliminate things like task switching, eliminate unnecessary hurdles in the development process. So we should be doing things like creating well-organized code bases, creating up-to-date, well-structured documentation. We should be making sure that we are setting well-defined tasks for developers with clear objectives so that they can onboard easily into our projects. And we can have entire dedicated DevX teams who can work towards self-service tools to help developers to streamline the steps required for developers to onboard, to release, to debug. There's a whole area of things that we can look into here. We should be considering things like presenting information in different styles. So allowing people to learn through the method that works best for them. So are they visual learners? Would they rather dive straight into a code example? Would they rather have a step-by-step tutorial? Allow developers to use the tools that best aid them for their own cognition. Because when our cognitive load is well balanced, we find it much easier to be efficient and to be productive. And it allows for this thing called flow state to happen. And I'm sure you've all felt it before, or you've heard somebody say, I'm in the zone when I'm programming, like I'm really focused on that thing. Or people have said, like, my flow was interrupted because I've got too many emails or too many meetings today. And this idea of being in the zone is flow state. And it's a mental disposition in which a person becomes fully immersed in the activity that they're performing. It's actually quite an enjoyable feeling. When you're in the zone, you are more creative, you are more innovative, you feel more motivated, and you will find yourself being more efficient. And when you're in that flow state, learning actually becomes much easier, and you will find yourself retaining information much easier. And it can make things like repetitive tasks actually feel quite gratifying. And this can cause us to perform better as developers, produce higher quality products, have better innovation generally. So it stands to reason that we want to try and create an environment where developers can maintain this flow state. So in order to do this, there's a few different things we can do. Firstly, the most important thing is you want to make sure that challenge and skill level required to complete that challenge are well balanced. So tasks should present enough challenge that the mind is engaged and learning, but not confused or frustrated. Too much challenge can leave the developer feeling helpless, leave you feeling foolish, like you can't complete a task. And on the other end of the spectrum, tasks that are too simple can leave you feeling babied, bored, and belittled. I remember once my dad called me and he said, my computer is broken. And I was like, why don't you just look up how to fix it? There's this thing called Google, And his response kind of surprised me. He said, I can look up how to fix this thing on Google, and I can spend 2 hours trying to find an answer to why my computer is broken. And after 2 hours, I still won't be certain that I have found the fix. I don't know I don't have enough skill to reach this challenge. Whereas I can call you, you can look up why my computer is broken, and you will probably understand within the 2 hours why it's broken, and you will have a fix. There is a certainty there. Your skill level is matched to this challenge. But because his skill level was so unbalanced with this challenge, he just gave up before he'd even started. So we need to make sure when we're building experiences for developers that we are considering the skill level that they have and what challenges we're presenting them with, and make sure that we're catering accordingly. We want to create a confidence in developers that if a task is unexpectedly complicated, we are going to be able to handhold them through it, and they are going to get there in the end. And getting this balance of challenge and skill right is what allows developers to feel like they are in control of the process and that they are picking the right tools. And clearly defining tasks and setting achievable goals can really help with this. Completing tasks allows developers to feel a sense of achievement. We will love it when you tick things off your to-do list. It helps you want to do the next thing and the next thing and pick up the next challenge. And it helps you stay in flow state and removes the chance of boredom. And conversely, things like interruptions, distractions, and delays will all hinder your flow state. And anytime you struggle to find information that you need or have too many tasks that you need to do at the same time, you're going to be pushed right out of that flow state. So if you're constantly being pinged or distracted in an office, for example, or if you have to toggle between too many pages to read documentation, it's like, imagine a runner on a track. Every time they have to do a new task or every time they're distracted, it's you putting a brick out in front of that runner, and the runner's going to trip over. And then they have to get back up again and start running again. And that takes more energy. And every brick that you're putting out in front of that runner, it's going to take them more energy to pick up, and they may just give up. Switching between tasks, getting lost or frustrated or distracted while you're searching for information can not only, knock you out of flow state, but it can also make you feel anxious. It can make you feel frustrated, and that's going to reduce your cognitive load. Increase your cognitive load, And flow state depends on developers having the autonomy and the opportunity to work on challenges that they find fulfilling. And the best way to find out whether you've got the balance right, so whether the developers are feeling like their skill level matches, is to get feedback from them, which brings us nicely on to feedback loops. So it feels like a really obvious thing to say, but sustaining meaningful feedback loops between developer effort and the impact that they're having is central to creating a good developer experience. How can we know that we're doing a good job at creating a good developer experience if we're not asking developers whether they're enjoying the experience? Feedback allows us to spot mistakes, it allows us to learn and improve, but it also fosters a feeling of visibility within our communities. So if you're looking to improve your developer experience, you should be aiming to have as short a feedback loop as possible. It's imperative that you make giving feedback really easy for developers so that they feel like they can talk to you. But it's also important that you action the feedback that they give so that they feel like you're actually listening to them. And doing so will allow you to discover where developers are struggling in your processes, where you've accidentally placed those bricks out in front of them and they're tripping over. And it'll ultimately lead to you building more beloved products. And similarly, we should be looking to provide feedback to developers as they use our products. We should be getting feedback to them nice and quickly as they work so that we can keep them in that flow state and let them know that they're on the right track and keep them motivated. So things like having great test coverage in the things that we're writing allows developers to know when they've made a mistake, change it, immediately move on to the next thing. We should be enabling continuous integration so that they can run their tests while they're working and get feedback immediately. We should be offering nice, clear steps in our onboarding, things like, how do I install dependencies? How do I get started? How do I run this project? What do I do when I want to build this next thing? Give me nice step-by-step tutorials with a clear indication that I have succeeded so that I can know that I'm doing the right thing, that I'm onboarding in the right way. Providing slow feedback can leave developers in the dark, or it can interrupt them mid-flow. And obviously, no feedback is just not helping them at all. And feedback itself could be feedback is an entire talk in itself, really. And I've put a link here to an excellent article by Tim Cochran, the technical director of ThoughtWorks, who's written an entire article on feedback loops, how to implement them, how to measure them. I highly recommend reading that blog post. So the next thing to talk about when we talk about developer experience is measurement. And the eternal question for developer experience is, how on earth do I measure this? How do I know whether the changes that I'm making are having a positive impact or a negative one? And DX encompasses so many different aspects. It's challenging to quantify, but here are a few common things that you can measure. So firstly, as I mentioned, get feedback from your developers. So it can be as simple as conducting a survey, asking for a little feedback at the end of a tutorial, and get suggestions directly from them about where they stumbled, where you can improve. We can use things like Net Promoter Score to tell us whether or not our customers like our products, whether they would recommend us. There's also Customer Satisfaction Score, which lets you know at the point of sale. So at the point at which the developer decided, yep, this is the product for me. Why did they decide that? What was it about your tool or your product or your library that made them want to use it? And these can help you sort of gauge overall satisfaction. And you should be tracking this within your internal teams as well. So I'm not just talking about the external products that we're putting out, but you should be doing regular check-ins with the people that you're working with about where they think improvements could be made in your flow, in your internal documentation, and track things like, as sad as it is to say, track things like employee turnover. You can get absolutely vital information at exit interviews about where in your process things are broken and where you can improve things for developers who are going to come in the future. Then we can look at things like code quality metrics. So we've got code review feedback, code complexity, code coverage, how many bugs are being worked on over what period of time, how many issues are reported on GitHub. You can track these metrics over time and then see how they're changing and see whether the changes that you are making, so documentation improvements, more tutorials, more demos, whether those are making the impact that you want to see. Make sure you're also checking documentation quality. So is your documentation accessible? Are you including code snippets? Are you including full working examples? Is it all up to date? Have you included different ways of working? So have we got a video as well as maybe written? And regularly check. Trim out anything that is out of date or that is misleading or that is confusing people. Then we've got things like KPIs, we've got our burn down charts, our Kanban boards, number of completed story points. The more we improve internal developer experience, hopefully, the more our developers will be productive. They will be able to improve the number of features developed, reduce the number of bugs that are worked on. Basically, you're measuring your team's productivity and you're tracking it over time. And there's an absolutely excellent research paper by Kat Hicks from Pluralsight, who talks about this idea of developer thriving rather than developer productivity. And she's written an excellent paper, which I have linked here, on how you can assess the effectiveness of the communication within your team and the collaborative tools that you're using, and how you can measure this idea of developer thriving. Measure things like frequency of meetings, email communications, how much people are on Slack, how many questions are being answered on Slack. Are your teams very active? Everybody's shouting into the void and nobody's responding. Get a good idea of how much time developers are spending on different things. How much are they actually in the code and how much are they in meetings and how much are they trying to get answers from other people? And things like, what time are they responding? So if you find your developers committing code at midnight or answering Slack messages at midnight, it might be a sign that there's some dysfunction there and your developer might be close to burnout. These are things that you need to, keep an eye on. Even things like participation in training programs or getting certifications or developing skills. If your teams aren't doing these things and they just feel like their noses to the grindstone all the time, that should be another smell. That should be another indication that maybe your processes, your developer experience isn't where it should be. We want to be allowing developers to have the tools to improve themselves and do their jobs effectively. So we want them to be doing training programs, to be doing certifications, to be improving their own skills. And then we have the development cycle itself. So there's so many things to measure here. We can analyze the time it takes to move from an idea to a deployment. Obviously, the shorter deployment cycles, the better, the smoother the development process. We can measure the time that developers spent debugging versus building features. We can track how frequently code changes are deployed to production. So a high deployment frequency suggests we have an efficient development and release process. And remember, DevX, as I mentioned, is multifaceted. There's so many different things that we can measure here. They're not all going to be relevant to everyone. You're going to need to sit and look at your own processes and make decisions about what it is that you should be measuring. And we're going to have to consider a combination of both quantitative and qualitative metrics, which can be quite difficult to measure in order to get a full understanding of what our developer experience is like. But make sure that you are regularly collecting and analyzing these metrics, because you can't understand where your current developer experience is until you start collecting some measurements and some metrics. And the overarching goal of the developer experience is to provide a smooth and efficient and pleasant experience for developers. And I tend to think of DX as split into these two separate parts. So we have internal developer experience and external developer experience. So our internal developer experience is the teams that we're working with, the people that we work with directly, that we have access to, that we can speak to, and we can get an idea of what they think, what tools they would rather be using, where they think improvements can be made, how frustrated they are. We have a good idea of who these people are. Then we have the external developer experience, which is going to require a lot more research. We're going to need to make decisions about who it is that we actually want to reach with our products, and then what skills it is that they have, whether we're aiming the documentation that we're writing at the correct people, whether we're aiming the websites that we're writing at the right people, how we structure our code. These are all considerations based on who's going to be using it, who's going to be reading it. And of course, you are going to interpret the information in this talk and make it relevant for your own teams and your own products. But I would like to give you some practical takeaways. And these are things that I've seen out in the wild that I think make a big difference, and things that I've seen that I think reduce cognitive load and help me stay in the zone a bit more when I'm working. So let's start with the absolute basics. There are some standard hygiene practices that might seem really obvious, and you're going to go like, Joe, like, we get this, like, this is really obvious, but you'd be surprised with what I have seen out in the wild. So I'm going to go over each one and talk about why I think it makes a difference, and how you can use this to improve your own developer experience. So the very first thing, a good code base should follow the default language convention of the language that you're working in at the time. And anything that deviates from these standards, no matter how clever you think you're being, no matter how well-intentioned it is going to cause more cognitive load for the developer. Every change that you make to these standards, however clever you think you're being, what you're actually doing is you're raising the barrier to entry, because you're placing that brick in front of the runner again. You're doing something unexpected that puts a bit more cognitive load on the developer, makes them have to think. Remember that every new tool that you add to your project, every dependency that you add is, again, increasing that cognitive load. It's another thing that the developer has to understand before they can start using your code. It's just raising the bar, putting those little bricks out in front of the runner. You can reduce time spent onboarding by making use of dev containers or code spaces. And if you've not used them before, containers are lightweight packages that include all of your application code together with its dependencies. They create a full developer environment with minimal setup. So we don't need to have complicated dependency installation. We don't have fears about platform compatibility. And GitHub offers code spaces that allow you to run your containers in the browser. So it literally could not be easier. And VS Code has a containers extension as well, which allows you to use a container as your full-time dev environment. And this is just a nice way to onboard developers much more quickly into your code base. And if you can't use a dev container for whatever reason, at the very least, try and avoid global dependencies. This will ensure that your project can be easily installed by the developer that's trying to use it. And it helps maintain the integrity and the stability of your projects across different setups. I am a Windows user, and I fall foul of this all the time, being a JavaScript developer with a bunch of other JavaScript developers who are mostly on Macs. And if you can't avoid external dependencies, then please script them. So if we go into our package.json, there's a script section. We can define custom scripts that will be executed with npm or yarn, and we'll do those installations for us. But again, remember, differences across operating systems, different commands may be necessary. So double check that everything you're writing runs across platform, please. Next, let's talk about READMEs. These are a really crucial part of your repository, and the number of times I've seen an empty README or a README that only has an H1 in it. The README is the initial point of introduction between you and this developer that you might never, ever get to meet or talk to or explain your intentions to. It helps users to quickly understand what your project's about and why they should be interested in it. And a well-crafted README enhances the accessibility of your project. It helps developers understand why you made the decisions that you did. And investing time in crafting a great and comprehensive README will really improve the value of your project, will really improve the developer experience, and will help foster engagement with the community. So when I look at a README, these are the things that I would like to see. First up, if the README is long, give me a nice table of contents at the beginning so I can jump to the place that I need to be. There are generators online. If you're writing Markdown, just paste your Markdown. They'll generate a table of contents for you. There's even a VS Code extension, so there's no excuse not to be making these. Then start the README with a brief introduction to your project. So describe its purpose. What are its goals? What are its key features? Why do I want it? What problem is it solving for me? Then I want to know how to use the project. So what do I need in order to run it? For example, what version of Node do I need if it's a JavaScript project? How do I build it? What commands do I need? How do I run it? Give me some nice code snippets that I can just copy and paste so I don't have to think. Like, really hold my hand through this process. Provide instructions on then how to actually use the project once I've got it installed. Explain to me the main functionalities, how I interact with your code base, and include things like code samples, include usage scenarios. Again, give me code snippets that I can copy and paste. Then let me know if your project requires any configuration. Give details on the configuration that I'm going to need, how I can customize this project. Again, a nice code snippet really helps here. Give a whole example file of the configuration that I can just copy and paste and fill in the blanks. And then let me know any constraints in your project. So any particular gotchas that I might hit Tell me about those bricks before I fall over them. Any design decisions that you've made that you think need to be called out, call them out here. Don't leave me guessing about the decisions that you've made. And then there are other things that you can add to your README. So these can either be in the README itself, or we can have separate standalone Markdown files. So really important on outline guidelines for how I can contribute to the project. So how would you like contributions? How would you like them written? How can I run the tests in order to get going on a contribution? How do I submit a bug report? How do I propose an enhancement? Specify any coding styles that you're expecting for PRs, any linting rules that you want me to follow, any testing frameworks, or anything else that you want contributors to follow. Make it as easy as possible for people to make contributions. Provide also your contact details for, this can either be an email address or a forum or a Twitter handle or a Discord, some way that developers can get in contact with you if they need to ask a particular question, and encourage users and contributors to reach out and ask for help, give bug reports, or collaborate. Make sure to also, if you're doing this, include a code of conduct. So this is going to explain the behavior that you expect from anyone who is collaborating, that you expect from the community. And not only that, what will happen if there is a violation? So how are you going to handle violations? Clearly state the license under which your project is distributed, and mention any restrictions or particular requirements for using it. A well-written README is going to massively improve the clarity, the usability, just the pleasantness of the developer experience of your projects. And when we're writing a README, we are often going to need to do this thing, which is technical writing. And this can make a huge difference to your README. And maybe it's not a README, maybe you're writing a blog post, or maybe you're writing a tutorial. Technical writing is a skill in itself. What you're doing is you're breaking down complex concepts and making them accessible and digestible. And an important component of good technical writing is understanding who you're writing for. So before you even, put your fingers on that keyboard and start typing, consider your audience and get a good understanding of who the person is that you're writing for. So what is their role in the company that they're at? What do they care about? What's their technical expertise? What is their responsibilities? Are they beginners? Are they intermediate users? Are they experts? Who is it that you're speaking to? Once you've identified exactly the audience for the things that you're writing, then you can do something called creating a persona for them. So create a fictional person, give them a name, a background, a storyline for why they have ended up on your README and what it is that they want to know. And then when you are writing, write with them in mind. This way, you're going to target your information correctly. Then these are more general advice. So use simple and direct language when you're writing. Convey your message as clearly and concisely as possible. Try and keep a consistent tone of voice, a consistent use of tenses and nouns and points of view. I have seen so many READMEs where it said, we are going to do this, we are going to do this, you are going to do this, I did this. And I'm just like, who's doing this? Write nice, low complexity sentences. Don't labor the point. Try not to repeat yourself. Use low complexity vocabulary and keep your paragraphs nice and short, and give frequent examples. So if you're telling me to do something, also give me an example of how to do it. Focus on legibility, readability, and accessibility. So use headings to break up large blocks of text. Write descriptive link texts. So links should make sense on their own as a standalone, as well as in a sentence. And of course, give your images descriptive alt text. Use inclusive language when you're writing. think about ability-specific language. So instead of saying, see this thing, say, read this thing. Instead of saying, look at this thing, say, check out this thing. Try not to refer to things as crazy or dumb. Instead, use wild or baffling. And there's no need for gendered language when you're writing. I hope this is something we've all learned already. We can swap out words like man hours for work hours, that kind of thing. And avoid using idioms or slang. These can confuse people who don't speak the same first language as you. And then finally, avoid saying that a process is easy or simple. This can make folks who are confused or who are new to a subject feel like they're being belittled. If you say, do this in 3 easy steps and I'm stuck on step 2, I'm like, oh God, I can't even get through the easy thing. There's no way I'm going to be able to, use this tool. So instead of easy, just say, do this thing in 3 steps. I'm like, 3 steps? That's not much. I can do 3 steps. I don't know about you, but I have a really short attention span. And when I see a huge block of text, my eyes just kind of slide off it like it's Teflon. So I really appreciate it if you break up walls of text with headings, with images, code samples, anything to illustrate the point that you're trying to make. And this also helps to engage people who perhaps don't learn best by reading, who want a more visual approach to learning. And consider, as I said before, different learning styles. So if you can offer this information in written format, maybe also offer video or audio, offer a full code demo where I can just dive in and look at the code if I don't want to read anything, a step-by-step tutorial if I want you to literally hold my hand through the process. Offer a whole load of different ways to learn. And the final thing that I want to talk about today is the code itself. And these are just a few things that I think can make a real difference to your code bases, because we spend the majority of our time with code reading it rather than writing it. So it's really important that the code that we're writing, we're thinking about who the reader is and what it is that they want to understand about this code, and that we write it as clearly as we possibly can. Because as I mentioned before, it's very likely that you're not going to get to talk to the developers who are using your code. You're not going to be able to explain your reasoning to them or explain the decisions that you made. Your explanation has to be within the code itself. So your code should be as unsurprising as possible. It should lower the cognitive load as much as possible and allow developers to stay in that flow state as they're reading. You want to think of it as like picking up your favorite novel and reading through a story to understand what it was that you were thinking when you were writing this code. So, to that end, these are a few things that I prefer to see in my projects. So firstly, write pure functions. So functions without side effects that do only one thing. They're much easier to read. They are solely dependent on themselves and they won't affect external state. They won't do things that will confuse us or surprise us. It means readers have less head compute. They have less to keep in that quick access memory, less to maintain as they're working through the code. We're reducing their cognitive load. Functions with fewer arguments are generally easier to comprehend while you're reading code. The more arguments you have, the more I need to go, okay, so that's something I need to remember. What's that thing? Okay, that's another thing I need to remember. What does that do? If you can, refactor your functions to make them smaller and reduce the number of arguments. Promises are more readable and more intuitive than nested callbacks. They make it easier to follow the linear flow of the code. So you're trying to understand the instructions of each step. And promises just result in more concise code blocks, which again are easier to maintain the flow of the logic in your head. It just makes it easier to understand the flow of the asynchronous operations of the code. And again, we're aiming to reduce cognitive load. Return early and often. By replacing your return statements at the top of your functions, at the beginning of your functions or your methods, you're immediately communicating the conditions under which the function should exit, which is going to, again, reduce our cognitive load. If we go through the code and we say, oh, okay, we've got to this point here, we exit, I don't even need to read the next bit. This is the bit that I'm currently interested in. Again, it's minimizing the need for the developer to hold multiple conditional branches in their mind as they're reading the code. So try and return early and often. And then avoid nested ifs if you can. So avoid the pyramid of shame. As your nesting level increases, the code becomes more convoluted, it becomes less legible. It's much more likely that the developer is going to make a mistake as they're reading it. It's going to be much harder to follow the logic and to understand the intention behind what you had written. The pyramid of shame leads to bugs, leads to maintenance issues, and of course, again, increases cognitive load. We're making them hold more things in their head. Try and use descriptive language when you're naming rather than abbreviations. I know it's nice to abbreviate and have nice, neat function names, but if you describe what the function does, it makes it much more obvious as the developer is reading through, what's happening in this function. Oh, it's already described in the function name. Excellent. The code becomes self-commenting. The goal of writing clear code is that when you read it, you can immediately understand what the code is doing. And if we describe that in the name, it's just giving a little extra help over that brick. You may be tempted to write comments, but comments are either lies now or they are lies in the future. And I understand sometimes you have committed some sort of cardinal sin in your code and you need to just put a little explanation in there about why that happened. And that's fine. Sometimes we need to do that. A story doesn't go amiss as to why something is the way it is. But comments should tell you why the code does what it does and not what the code does. The code should explain itself, and then the comments explain like why this thing happened or what you were thinking when you were doing that. And now it's time to make everyone in the room really angry. I really like long lines of code for education. So if I'm writing code that I know someone is going to read, long lines can be a really helpful tool to make our code more readable. And, I can see all the Vim users getting their pitchforks ready and everybody who likes 80 character line linting. But let's take a look at a visual example. I want to see if I can bring you along on this train with me. So here's some example code, and you might not be able to read it, but the important thing is that you look at the shape of it. So this is from an SDK that I wrote recently, and it's an endpoint that returns artist data. So I don't know if you can see at the top here, we have a default class artist endpoint, and then we have a bunch of functions. So we've got albums, top tracks, related artists. And I think that this is well-written code judging by the outlines that I just gave on the previous slides. So the classes and the functions are nicely named. They explain what they do. The functions do only one thing. I have got a comment in there. I don't know if you can read it. It says, bug market is flagged as optional in the docs, but it's actually required for this endpoint. Otherwise, you get a 400. So this is just explaining why there's a difference from what is happening in the code to what is happening in the docs. I will then later go on and update the docs and hopefully be able to remove this comment, but it explains why, not what. And yes, the albums function in particular has a lot of arguments on it. I don't know if you can see just here. Unfortunately, that's just that particular function just has a lot of different options, but by putting all of these parameters into one line, it's sort of like saying to the reader, don't worry too much about these. We'll come to them later. You don't need to actually think about them. You don't need to process them. Don't head compute them. We'll get to them later. By shoving them off onto the right-hand side of the page, we're kind of saying these are less important. You don't need to think about them. not only is your left to right hand side space changing importance, so things on the left hand side are things that you really need to be concentrating and reading, things on the right hand side don't worry about. Vertical space also means something. It gives an importance to the information. So a new line sort of implies to me that this is a new concept. It's kind of like a paragraph in a novel. It implies a new section of code. So be it a functional or a logic block, new lines help with cognition. They help you understand what the code is doing, which bits of code relate to which other bits of code. Our brains can understand there's a new line here. This probably means a new concept, something that I need to separate out when I'm doing my initial pass through in my head. So now, looking at this beautiful block of code here, let's run it through a linter and see what it looks like with an 80 character line length max. When you run your code through a linter that is going to create a new line after every 80 characters, you're potentially lending significance to lines of code that aren't so important for your developer to read on the first pass through. For me, it's kind of like you hit return in the middle of a sentence that you're typing. It suddenly doesn't make as much sense. It's much more difficult to read through and get the meaning. So let's take a closer look at this. So let's start right at the top of the file. I've got a bunch of imports there. So before I had all of these imports on one line, right at the top, line 1, went right off to the right-hand side. You probably didn't even see it. It's so unimportant. It's literally there because we need to satisfy JavaScript's module system. It's not something we need to really care about. It's detailed information, but I don't need to know about it yet because I haven't even looked at where those imports are being used. But now it's been split over, what is that, 7, 9 lines, something like that, and it's taken the important part of the code, the actual class, and pushed it all the way down the file. Suddenly, there's a huge amount of head compute that I need to do before I've even started reading the code. More cognitive load on our user. Not only that, but it's removed some of that white space that I put in there to intentionally signify different blocks of code, different concepts. So I've got my class there. So then I'm declaring functions on that class. These are 2 separate concepts. This is my class definition. These are my functions. I put a new line in between them, which is now been removed. It's frustrating. It's changing the meaning, changing the intention of what I had written. The next block of code, thankfully, has been left unadulterated, but that lack of space just adds to our head compute. Again, it just makes it a tiny bit more complicated to read. Next, let's get on to the really offensive stuff. So all those additional parameters for that albums function have now all been put onto new line. And not only does that make you read each one and have to think about each one and parse what it's doing, it's also changed the expected shape of a function. So when I see a function, I expect function name, parenthesis, parameters, curly braces. But this has changed the shape of it. So now I've got function name, parenthesis, and a whole bunch of new lines. And now I've got a line which is used especially for a parenthesis and a curly bracket before I get to what the function body actually is. And it just, again, it's putting another brick out in front of a runner. It's just increasing that cognitive load because it's not the shape that I expect it to be. It's making me instantly just do a little tiny bit more work. And then if we have a look at the top tracks function there, that's been split over multiple lines, especially so that we can have a bracket semicolon having its own line there. I'm sure that was very important. It changes the meaning, it changes the importance, it changes the flow of the code as you're reading it, and it just makes it a tiny bit more confusing to me. And our related artist function there right at the bottom has escaped the tyranny of the linter unscathed. So at least we can be thankful for that. But, importantly, we've added all this extra cognitive load, but we have saved ourselves 3 kilobytes. So I'm sure the developer will be very pleased. I don't know about you, but when I look at these two things, when I look at the one on the right-hand side, I get that same panic that I get when I see a big wall of text. My eyes start to slide over it because I can't read it. It's not shaped like I would expect it to be. So I'm really sorry, Vim users, and I'm sorry, ESLint default setting users. I just don't think this is better. It's not 1996 anymore. We all have widescreen monitors. We should all be considering the readability and the legibility of our code. We should all be thinking about the reader when we are writing code. So what I am trying to say is my name is Joe Franchetti and I love long lines. This has been a very whirlwind introduction to developer experience and the things that I personally think can change developer experience. We talked about what makes up developer experience. We talked about how we can measure developer experience and some more practical examples that I have seen that I think can make developer experience better out in the wild. Thank you all so much for listening. I have put the slides up here. So if you do want to read any of those articles that I linked to, you absolutely can do. The speaker notes also are included. So if you would rather read what I just said than listen to it, you absolutely can do. There's a full script there as well. Thank you so much for listening. I'm not sure we have much time for questions, but I will stay around. So come chat to me after. Thank you so much.